Hi, thank you for joining us today. I'm Nick Bray from NBA. NBA is an architecture studio based in Vancouver and Victoria. I'm currently in Vancouver on the unceded traditional territories of the Musqueam, Squamish, and Tsleil-Waututh nations. Our team's aim is to make a positive difference by creating innovative, sustainable, and community-focused buildings. I was recently asked why are we hosting these seminars, and there's two main reasons. Firstly, there's a lack of affordable and accessible education for architects. There's a lot of courses, but they tend to be more expensive and longer in length. And personally, I appreciate shorter courses that provide an overview of important subjects from which I can then carry out further research if I need to. I also like saving money. I don't like spending money on expensive courses if I can avoid it. Secondly, architects, more than other professions, we've become accustomed to being competitive with each other rather than helping each other and standing together. I think fire stopping is an example of a subject that I feel that everyone in my firm should be up to speed with. And based on the large numbers of you attending today, it's clear that you feel the same way. Celerity Engineering, Brian and Gianni, they've been kind enough to give up their time today, so it makes sense that they teach us all at the same time. So that's why we're doing this. The next seminar, Seminar 6, is on June 18th. It will be a deeper dive into the implications of the recent seismic upgrade requirements in the 2024 BCBC, and that will be by RJC engineers. We previously discussed these requirements before they were implemented, but we can now talk to their actual impact, specifically relating to mid-rise buildings. We'll then be taking a break over the summer, but we intend to provide more courses in the fall. I hope the first will be about using artificial intelligence as part of our workflow, beyond the typical chat GPT and Photoshop generative AI that we're currently using. If you have any ideas for seminar topics relating to issues that are affecting your work, please do put them in the chat box or email me. Yeah, we'll try and set up future courses relating to those ideas. On the subject of the chat box, also, please use it to ask any questions you have during the seminar, and we'll endeavour to answer them at the end of the seminar today. The AIBC accreditation form link will be provided. We'll provide it halfway through the session and also at the end. So please have your AIBC number ready. It's a very simple form and automatically sends those details to the AIBC. And yeah, thank you very much for filling out the polls. We're 90% architects, some engineers and others, and good, yeah, good showing from Vancouver Island, 16%, but mainly Lower Mainland here, 71% of you. So thanks for filling that out. It helps us to angle these future seminars that we're putting on. So now like to introduce Brian Fraser, the principal of Celerity Engineering, and we've had the pleasure of working with Brian and the wider Celerity team for many years now. So over to you, Brian.
Great. Thanks very much, Nick. It's been a pleasure working with you as well. Today we have a wonderful presentation. It's going to be given by Gianni Vulcano, who's here in our Victoria office. He is an engineer and CP, and yeah, he's been with us about 2 years now, which has been great. Um, so today, yeah, we're looking forward to working with you as well. So Jenny, if you want to take it away.
Sure. Yeah. Thanks, Nick, for setting this up and hosting this. I think it's a great opportunity for everybody to learn a little bit about fire stopping. Thanks, Brian, for the intro. So you mentioned I'm a engineer and certified professional. I live and work here in Victoria. My background is started off in more in the industrial sector, working in food processing facilities and some light manufacturing. And since have expanded that to residential, commercial, and a variety of other types of occupancies and buildings. And since moving to Celerity Engineering, have expanded that even further. I also have some experience in applying NFPA 13 and other NFPA standards as it pertains to fire protection and code compliance. I guess jumping right into it, why do you guys need to know this? It looks like the majority of you are architects, so that's great. As you know, as you have a professional responsibility if you're the professional of record for fire separations and their continuity. So this often will deal with closures like doors and windows and fire dampers, but often fire stopping is how that's provided. I mean, it is often a gap, especially during construction, because it's a shared responsibility you have with other professionals of record, particularly mechanical, plumbing, and electrical. Interestingly, fire suppression is not explicitly required in their Schedule B to ensure continuity of fire separations at fire suppression piping penetrations. This will usually fall to the plumbing engineer. But for you as architects, it's good to know what your responsibility is, what other people's responsibilities are, and making sure that we coordinate as a team and everybody's doing their due diligence and fulfilling their professional obligations. As an architect, say on site, you would likely be responsible for the specifying the fire separations themselves. You may not necessarily be required to specify something like fire stopping for a water pipe that's penetrating the separation. However, it's good to know that if you did specify something as a fire separation, for instance, that there is some type of fire stop system being implemented, even if you don't necessarily know if that system complies or not. That might be the plumbing engineer's responsibility, but it's good for you as the architect of record to be aware of those requirements and make sure that when you're on site or when you're reviewing shop drawings that you are looking for those types of things. Further, as potentially see the CRP as well, making sure that these details are being coordinated and that everybody's doing their due diligence is important for obviously fire safety and code compliance, but also just successful project completion. So today we're going to talk about fire stopping, primarily part 3 requirements. Part 9 also covers fire stopping. Much of it's the same, but there are a few differences. We will focus on part 3 though, so if there are some differences in that part 9 covers, we won't really talk about it. We might point out a few here or there, but it's not really going to be the primary scope of this discussion. We'll primarily talk about continuity of fire separations, and we'll look at the different types of penetrations and that are affected and require fire stopping. 4 main ones: construction joints, perimeter fire containment, service equipment penetrations, and membrane penetrations. Any other type of closure that's used to maintain the continuity of fire separation, such as doors or wired glass or dampers, etc., won't be covered in this. So we'll start off with discussing some key terminology. First being fire separation. I've already said it a few times. It's a construction assembly that acts as a barrier against the spread of fire. There's 2 main types: a horizontal fire separation and vertical fire separation. Horizontal fire separations are things like floors, ceilings, and roofs. They resist the spread of fire vertically, from story to story, whereas vertical separations are things like walls and partitions that prevent lateral spread of fire. Quick note that some other regulations refer to horizontal and vertical fire separations as well, but might refer to them kind of in the opposite, saying that a horizontal fire separation prevents the spread of fire horizontally, which can lead to confusion. So just beware. You guys will primarily be dealing with the BC Building Code, but if you are reading some other supplementary documentation, just be aware of the terminology used there. When the code refers to fire, it refers to all products of combustion. So that includes soot and smoke and heat. which is important because not all fire separations require a fire resistance rating. These are often referred to as smoke separations. And this isn't always directly addressed in the building code. However, it is good to know and good practice that if you do have a 0 hour fire separation, you may not necessarily need fire stopping, but you should, as good practice, provide some type of smoke seal so that smoke leakage doesn't occur through that separation. Fire resistance rating is the time in minutes or hours um, given to a construction assembly that's been tested in accordance to CAN ULCS 101. It's the time that that assembly will withstand the passage of flame through it. Rating can also be assigned on the basis of Appendix D in the building code. There's an appendix at the back where you can essentially add different components of assembly, say wood studs with a gypsum wallboard membrane, and attain a fire resistance rating based on that. That's based off of testing of individual components and not the assembly as a whole. So often those ratings will be a little bit more conservative. There are also assemblies in Part 9. There's Table 9.1.10.3 A and B. Part 3 allows the use of some of these assemblies, namely M1 and M2 sealing membranes and the C1 sealing assembly. However, any other assembly is not permitted. So this is another important note. It's fairly common for us to see architects specify a wall assembly in a Part 3 building from Table 9.1.10.3, and this is generally not allowed. I will just clarify that the STC ratings from those assemblies can be used, but you should be very careful when doing that, especially if that assembly does need a fire resistance rating. You have to, even though you're maybe using one of those assemblies for the STC rating, it doesn't necessarily comply as far as fire resistance rating goes. You need to use a listed assembly or determine that fire resistance rating on the basis of Appendix D. We'll also just quickly define the term membrane. It's not defined in the BC building code, but will typically refer to the outer layer of finishing material on a construction assembly. So in the little diagram below, you can see the gypsum wallboard membrane on the outside of this assembly is what's referred to the membrane. Can also be lath and plaster or cement board or plywood or a variety of other materials. Firestop. So this is a system of materials and components used to fill the gaps between fire separations themselves, so wall to wall or wall to ceiling, or between a penetration through that fire separation, such as a pipe or conduit or a duct. It's critical for maintaining the integrity of fire compartments. So fire compartmentalization is a key way that the building code implements passive fire protection to prevent the spread of fire throughout a building. And the critical aspect of it is that the integrity of those compartments need to be maintained. So that could be through closures, through fire resistive construction, and for the sake of this report or this presentation, fire stopping of penetrations and joints in those fire separations. Fire stopping must comply with CAN ULCS 115 testing. It can also be cast in place. The code, there's a note in the building code that kind of clarifies what cast in place means. And it's used to reinforce that there shouldn't be any gaps between the building service or penetrating item and the membrane or assembly it penetrates. Typically, it means fire stopping for service penetration through like a concrete slab or concrete wall. The previous version of the building code, the wording tightly fitted was also provided, similar to cast in place. That has since been removed. Interestingly, Part 9 does still have that wording, but for the sake of Part 3, it's no longer a valid, acceptable solution. And just because the actual requirements are very ambiguous and vague, and led to a variety of different types of construction that may or may not have been meeting the intent of the building code. So the testing used to determine the fire stopping rating is called CAN-ULC S115. Essentially, the fire stop systems are subject to the standard fire conditions within a furnace and subject to the standard ASTM time temperature curve. It's important to note that these are fire stop systems. You might see a contractor or someone refer to fire stop as like a caulking or a collar. That's one part of the system, but by itself does not provide an F rating or an FT rating. The whole system, so a specific wall assembly with a specific type of penetrant and a specific material used to seal the gaps. For instance, that's a system if it's been tested to S115 and achieves some type of performance criteria. So be very careful when reviewing these types of systems and make sure that there is an existing listing for it. Testing with S115, there's several different ratings that can be applied. The two most important are F and FT ratings. F is the fire endurance test. It's the time and hours that a fire stop system will prevent the passage of flame through openings in the barrier, whereas FT is the heat transmission test. In addition to the F rating, it also requires that the temperature of the unexposed side doesn't exceed 181 degrees Celsius above the initial temperature. There's other ratings like FH, FTH, and L. The H meaning host stream. So a host stream is applied at the assembly and structural integrity needs to be maintained. The L refers to leakage. So leakage of smoke through the assembly. L is a bit newer of a requirement. H is a bit older, but you won't really see those. You won't see those in the BC building code, but good to know about. Pressure differential testing is also optional. You'll see this for combustible piping penetrations. 50 Pascal pressure differential is required when testing. Not in all situations, but sometimes you'll need it. Also, movement cycling, this is for construction joints. So dynamic cycling is applied to the construction assembly to ensure that it can accommodate building movements and still resist the passage of flame. So where are fire stop systems required? There's two main types of subcategories of fire stop systems. We'll call them joint systems. So these are systems that protect from fire spread through joints of fire separation. So wall to wall, wall to floor, wall to ceiling types of joints. And then there's penetrations or a fire stopping of penetrations. These could be through penetration, so a penetration that goes all the way through an assembly, or just a membrane penetration. So something you might see in like a plumbing wall where a pipe is completely contained within the wall, except at one point it might come out to say like a drain for a sink, for instance. There are other opening protectives available, such as closures, smoke dampers, fire resistant glazing. As I said, we won't really talk about these. Wherever else the continuity of a fire separation needs to be maintained, typically a fire stop system is the system used to maintain that integrity. So there's a few areas where the continuity can be maintained without requiring a fire stop system. First is sprinkler heads, provided that an escutcheon plate is provided in accordance with NFPA 13, you won't have to fire stop that penetration. But it's important to note that this only applies to the sprinkler head and not the sprinkler piping. The piping would still require fire stopping. Fire dampers are another situation where you don't necessarily need fire stopping. Often the fire stopping can impact negatively the operation of the fire damper, and so often you'll see them without. However, there are some situations where dampers are specifically designed to be installed with a fire stop. So you should always double check installation instructions and data sheets to confirm if that's required or not. Smoke separations, we also talked about a little bit, are essentially 0-hour rated fire separations. They don't require fire stopping, but as I mentioned before, it's good practice to make sure that a smoke tight seal is provided wherever the continuity of those separations may be impacted. So we'll start with joint fire stop systems. These can be kind of broken down to two different categories. Typical joint fire stop systems between, like I said, walls and ceilings, or floor to floor. There's also perimeter joint systems. We'll start with just a regular old joint fire stop system. General rule of thumb, these need to have an FT rating. So that's the flame through rating, F, and then the temperature rise rating as well, T. The BC Building Code was rewritten a bit under the Continuity of Fire Separations article 3183. And in general, you'll see that most of the 2024 updates to continuity of fire separations and penetrations through fire separations, those updates mainly revolve around increased clarity around test requirements for these separations and fire stopping. Previously, requirements were a bit ambiguous and up for interpretation. I think the wording was that the continuity was allowed to be maintained by filling all openings at a juncture of an assembly with material that will ensure the integrity of the fire separation at that location. So it was kind of up in the air and at your discretion at what type of material will ensure that integrity. That wording has been replaced with better defined testing requirements, namely CAN ULC S115 a tested fire stop system. So FT rating isn't required everywhere. It can be waived for joints between ceilings and walls, floors and walls, and at wall corners where gypsum wallboard is used and attached to the frame in a way that would restrict the flame and smoke passage. So in this diagram, you can see here that there is the top plate of the framing is used as a backing where the gypsum wallboard overlaps. So flame through at this joint is not really feasible into this concealed space because of that, essentially the top plate acting as a fire stop. So that's an acceptable solution, and only an F-rated fire stop would need to be applied in this case instead of the FT rating. Further, joints between interior finish materials, so like say you have two gypsum wallboards attached to some framing, where those gypsum wallboards meet, fire stop isn't needed at all as long as smoke tight joints were created. So if you have, as long as it's mud and taped appropriately, for instance, that's typically sufficient. You wouldn't need any additional type of fire stopping. So here's one example of a wall-to-wall joint. So there's some concrete panels with a wall joint. You can see, for instance, some things to look for while you're on site if you are reviewing. This one has a little hole in it where where there's a penetration in this joint, affecting the continuity. So that's some little things to look for. This specific system down here is WWD009. So I don't expect that to mean much to you, but you can look these systems up, or if you are looking for a specific system, you can look these up on UL's website, UL Product IQ, and we can go through one together. The website is iq.ulprospector.com. I've also included a link at the end of this presentation, as well as a bunch of other resource links that you can use. If you are looking for a Firestop system. This site will have basically all the UL listed assemblies that are publicly available here. It's a huge database. So in this case, if we're looking for Firestop system or joint systems, there's a category here, joint systems for Canada. There's two. Make sure you pick the one for Canada if you're working in Canada, because there are differences in the way they're tested or required to be tested. And then within this database, you can search. There's a ton of items you can filter through if you want to find a bunch of different assemblies or Firestop systems with a specific F rating or specific joint types. You can see there's hundreds of different available options. In this case, we'll just put in our one we're looking for, WWD 009. Should come up this one option. This is it. Now, when you're navigating these, again, always good to check, it is certified for Canada. That's great. When you're specifying this, say in a drawing, this is typically all you need to note is that the system number, and the contractor should know where to look this up and make sure, find the details of construction so that they can apply them. At the top, it'll kind of give you all the ratings. So in this case, it's got an assembly rating of 2 hours, nominal joint width of 2 inches, and then class 2 and 3 movement capabilities. And then the details of the actual assembly below. So it'll provide, again, like I mentioned earlier, the Firestop doesn't just refer to the materials used to prevent fire passage through the assembly. It's the entire system because it's all tested as a whole. So in this case, the wall assembly has specific requirements that must be met in order for this Firestop system to be compliant. So minimum 5-inch thick, reinforced, lightweight, or normal weight structural concrete, or UL classified concrete blocks. That's number 1 here. 2 in A and B is the actual joint system. So you'll need a forming material, minimum 4 PCF mineral wool insulation. There's additional requirements as well. And then a fill or void cavity material. So this is often proprietary material sold by whoever, it might be Hilti or 3M. In this case, it's Tremco Incorporated. It's really important to note that if specific products are listed here, those are the only products you can use to achieve this listing. Even though Hilti or some other manufacturer might make a product that's almost identical, to comply with this listing, it must be the products and specifications used within the listing. So only Tremco Incorporated is valid here. It's important to note because if you're specifying this detail, say, in the design stage, once you kind of come to the construction stage, contractors are always just going to want to use whatever's cheapest and most easily available. And this product might not be it. So it's good to try and find listings that have numerous options, say, for the specific materials that are required. So that way you have a bit more flexibility. But that won't always be the case, and sometimes you'll have to find an alternative. And generally there are alternatives, but it might mean that the other aspects of the system here will have to be modified somewhat, say the form material or the wall assembly. So if you are pivoting and using a different system, make sure you kind of go through all these details and make sure that every aspect of that system complies. If you can't and you're stuck with a specific product on site and you can't find a listing that complies, there is an option to go with an engineering judgment where an engineer can write you a letter kind of looking at the system and essentially seal off and take responsibility for it, saying that it would be expected to achieve a certain rating, even though it hasn't specifically been tested. So there is always some options, but it's always best, and we always recommend to just try and comply with the code and try and catch this type of thing early on in the design stage. If you can use a more flexible type of system that has maybe some other options, or maybe you already have a backup, you know that there's some other listings that are very similar in wall assembly and joint systems, but maybe use a different product. It's good to be able to specify those options to provide the most flexibility in your design. Another last type of joint system is the perimeter fire containment system. This is typically what you'll see at like a wall joint or a curtain wall joint or exterior wall and floor assembly. BC 2024 BC Building Code introduced an actual test for this. Previously, it wasn't as well defined. Now ASTM ET 307. These joints must be tested in accordance with ASTM ET 307. It's similar in some ways to S115. You use the same fire or time temperature curve of ASTM E119. However, it does vary in a few key ways, namely that it's actually an intermediate scale test. You use a multi-story apparatus and you use real fire conditions to test the joint and assembly. Similarly to S115, you also apply cycling to the joint of force to simulate real world movements that you would expect in a building joint. Next, we're on service equipment penetrations. So again, you may not necessarily be the one specifying the fire stopping detail for equipment penetrations. This will often fall under what, say, the mechanical, plumbing, or electrical engineer. But it's good to know the details of these so that when you're on site, you know what to look for. For instance, if you know you've specified a fire separation at a certain floor assembly, you should be looking for penetrations through that floor assembly and making sure that a fire stop system is being provided. So for service equipment penetration specifically, typical requirements or general rule of thumb is that they'll have to be F-rated at minimum, and they should be non-combustible. However, there's exceptions to both of those. Some special cases where you would need more than an F rating are firewalls and 3212 slab penetrations. In both these cases, you'll need an FT rating. Firewalls are essentially fire separations with some enhanced protections that separate buildings. FT ratings will be required through these separations. 3212 slabs are basically floor assemblies above basement parkades that are common amongst several above ground structures, which is useful because it can allow you to design those above grade structures potentially with less onerous construction requirements. However, the separation between those above grade structures and the below grade storage garage does need the enhanced protection of a 3212 slab. So the slab will generally be a 2-hour rated concrete slab, and penetrations through it will have to be FT rated. The one exception is that if these slabs or if the penetrations are contained within the cavity of a wall above and below that fire separation, that 2-hour FT rated slab, only an F rating would be required for those penetrations. It's not super common, but it may come in handy if you do end up having, say, a fire stop that was provided that's F rated. An option may be to just enclose the penetration in a chase wall, for instance. Another special case where FT rating is required is horizontal service spaces. Generally, under the continuity of fire separations article 3183, this type of vertical fire separation will need to be maintained even through this horizontal service space that separates it. So you would have to construct an additional fire separation within this horizontal service space to maintain the continuity of the vertical wall here. However, Article 3642 allows you to omit that and maintain a continuous service space below. However, you have to provide an FT rating for fire stopped systems within that space. There's 4 scenarios where you can waive the FT rating and only provide an F rating. The first is when the fire stopping system or the penetrations contained within the cavity of a wall above and below the horizontal fire separation. That's similar to the 3212 slab exception. So in this case, you have the vertical wall and the equipment penetrations contained within that cavity of that wall above and below the horizontal service space. And so only an F rating would be required here. Second is where the concealed space of the floor ceiling assembly has a fire resistance rating. So in this case, for instance, so yeah, that would refer to something like a fire block. So the service equipment penetration is entirely within that horizontal service space. And if that horizontal service space has a fire resistance rating, no FT rating would be required, just the F rating. Third is where the fire or the penetration is located above a ceiling membrane. So that would be a situation like this where you have, say, a bathtub drain coming through the floor. If the service space is protected with a fire-rated membrane from below, just an F rating is required. And finally, if you have another horizontal service space conforming to subsection 364 directly above or below the floor, then penetrations through the one space to the other would only need an F rating. As I said, non-combustible piping is generally the rule, but there are exceptions. If you do want to use combustible piping, you have to be wary of potentially requiring a 50 Pascal pressure differential rating applied to the Firestop. So the Firestop, when tested, has to have a 50 Pascal pressure differential applied from the exposed and unexposed side and still achieve the same F or FT rating. This applies to water distribution piping, drain, waste, and vent piping, and central pipe and vacuum system piping. Combustible sprinkler piping is generally permitted as long as the two fire compartments are sprinklered. And under NFPA, typically the entire building would be sprinklered. So this is often the case. But be careful with situations where you have, say, an electrical room. Electrical rooms, you can sometimes omit sprinklers in there. And so in that case, no combustible sprinkler piping should be provided. One other note that the 50 Pascal pressure differential testing it only applies to buildings that are more than 3 stories, which is a new thing in 2024. The location of this pipe is also something to be careful with. Typically, drain, waste, and vent piping should not be, or combustible drain, waste, and vent piping should not be provided in vertical service spaces or shafts. Same thing with central vacuum system piping. Water piping can be contained in vertical service spaces. If you do, you can use a combination. And so you could transition, say, between combustible and non-combustible drain piping, for instance, as you can see in this example. Within this vertical shaft here, you have non-combustible piping. But as you transition out and into the spaces, you use combustible piping. This can make things cheaper, but you just have to be careful with the fire stopping that you're using here. It will need that 50 Pascal pressure differential applied. Electrical services such as wires and cables, typically pretty much the same as piping. Just an F rating is required. Where you're using combustible totally enclosed raceways, it's permitted in a concrete slab, but you need to maintain a 50 millimeter cover. One situation that's not really explicitly covered in the BC Building Code is structural member penetrations. Also, it's a structural member, say, penetrating, but the structural engineer doesn't really have an obligation to maintain continuity of fire separations. That falls under the architect. So it's good for you guys to be looking for this type of thing on site. If you do see, say, in this case, we have a stair shaft that's being penetrated by some structural beams. A fire stop system is required to be applied here. And just an F rating. There are ULC listed Firestop systems available for this, but in some cases, engineering judgments may be required. So one example of a surface equipment penetration, CAJ 2008. Again, we can go back to product IQ. This time we're going to Firestop systems for Canada. Again, if we know the number, we can look it right up. However, if you're looking for a general systems, you can also filter by whatever specific details you're looking at. So there's a variety of different penetrating items, non-metallic pipe or conduit. So that'll be combustible piping, generally metallic pipe, conduit or tubing, insulated pipe, etc. There's lots of options. You can filter by F rating, FH rating, FT rating, kind of whatever you want. In this case, the name of our system is CAJ 2008. So here it is. Again, always look for certified in Canada. That's critical. This particular product has a number of ratings available. F and FT ratings are usually the ones we're looking for, and in this case, just an F rating would be required. This is combustible, so another thing to look for, this 50 Pascal testing is explicitly stated. If you're using combustible piping, that's really important to check for that. So it'll specify again as it's a system, so the floor or wall assembly being used. One thing to keep in mind here, often especially with wall assemblies, a lot of these details will specifically refer to other listed wall assemblies, like a U300 series or V400 series type of wall. And so there may be additional requirements for that wall construction that aren't necessarily listed in the Firestop system listing. So make sure that when you're specifying these systems that, again, all the aspects that are specified within here are being adhered to. So if it asks for a U300 series wall, make sure that the wall is being used meets that description. Again, you'll see the penetrance here. So this is the different types of materials and penetrants you can use. There's typically a maximum size available, schedule 40, etc. It'll specify the annular space. So that's the space between the pipe itself and the wall assembly or floor assembly, the gap essentially between the pipe and the wall. And then the Firestop system. So in this case, it's a collar. Again, only one available material here or manufacturer. So it's good to have some backups or different options available. In this case, this is fairly generic. There's a number of different listed assemblies that say a 4.5-inch thick reinforced concrete floor with these same penetrants. Sometimes it's also useful to look up the manufacturer directly. So 3M or Hilti or PFP, all these manufacturers, you can usually look up Firestop listings that use their specific products on their website. I've included a couple links to some of those websites at the end of this presentation with some of the other resources. So good to know and good to know where to look for those. For instance, I think this is Hilti's Firestop selector. It's really nice. It's really easy to use. This link, again, is in the end of this presentation. You can kind of select whatever you want. This is for, well, let's go penetration type. We got a through penetration with non-metallic pipe conduit. Say we want PVC. Some insulation, and it's going through a floor, concrete floor. We need a 1 hour rating. So in this case, It says there's none available, so it requests an engineering judgment. Might be because there's insulation. Yeah. So now you can see there's a number of available listings pop up that all use um, Hilti's products, and you can go through and cycle different products, and it'll show you the listings that use that. Um, so membrane penetration is a little different than through penetrations. Membrane penetrations will only occur on one side of the assembly. It won't go all the way through. And it can be a little tricky to deal with sometimes. If the wall or floor that you're using that has the membrane penetration is a listed assembly, there may be a few ULC listings available, but generally there's not a ton. So be careful when specifying these things. Sometimes if you have a membrane penetration that's required, it may be better to have like a plumbing wall or chase wall in between your fire separation rather than have the penetration through the fire separation itself. It might just make your life a bit easier instead of scouring, trying to find a fire stop system that works or trying to get an engineering judgment for this penetration. Yes, so these are often not used with listed systems. Often you'll see these in fire resistance rated construction that's given its fire resistance rating on the basis of Appendix D. So under tables D2, 3, 4, A, B, C, and D, it gives you the option of providing a fire resistance rating based on kind of additive component method of applying a fire resistance rating. Be careful with this again, because it can be hard to find UL listed fire stop systems with this type of construction. Membrane penetration outlet boxes is another type of membrane penetration you'll see. These do require an FT rating. However, it's typically waived based on the size. So for a 0.016 square meter area, that's about 5 by 5 inch area. So typically you'll be okay, but something to keep in mind. If it's greater than that area, then an FT rating is required. Here's an example. You'll see these are two different contractors installed this. Obviously, one did a much nicer job than the other. Things to look for when you're on site, discontinuity, like this is not applied very well, and it may be an issue. Additionally, if you have or outlet boxes within a single fire separation, but are back to back like this, there are some requirements for separation between them. At minimum, you'll need a 600 millimeter distance. However, if you encapsulate one of them, or if you encapsulate them with sheet steel, 28 gauge, or a half inch gypsum wallboard, that's an acceptable solution. And then new in 2024, you can also Firestop each with an FT rated Firestop system, which is essentially allowing for the putty pack system, which you saw in the previous slide. Sealing membranes. So this is another little tricky one. It's same as before. It is a membrane penetration, but where you have a sealing membrane that's assigned its rating on the basis of table D2312 and Appendix D. These are fire separations that aren't really assemblies. The fire resistance rating is only being applied to the membrane material. So basically, a layer of gypsum wallboard, in most cases. They require an FT rating, typically because their service space is above them, which is very difficult to apply or get for just a membrane, like a gypsum wallboard membrane. There are no listed systems for membrane sealings. And so an engineering judgment will be required. So if you are using this or applying this in your designs, strongly recommend coordinating with other designers and the MEP consultants to ensure that you're not providing penetrations through it, because it will likely need the engineering judgment. So on top of engineering judgments, whenever you do run into an issue that you can't comply with the acceptable solutions, engineering judgments are viable options. Usually, they'll apply when listed Firestop systems don't cover specific field conditions. For instance, we have a recent client who they have a bunch of materials already ordered on site that they need to use, but those materials don't necessarily comply with the listed systems that they need to construct or use to construct their building. And we're providing them an engineering judgment to essentially allow them to use those materials in lieu of a tested system. They're essentially alternative solutions. Different AHJs will treat it differently. Some you will have to submit it to them for their approval. Some that may not be the case, but it's always a good idea to kind of touch base with them first before implementing these to see what kind of process they want to follow. Yeah, and not a substitute for listed systems where they exist. If you can just apply easily a listed system, that's always recommended, and that should be the first path that you take. But it's often the case that that's not really possible or not economically feasible, and so this is a viable route. Do be careful. Sites like Hilti or manufacturers like Hilti will provide engineering judgments at request, but these aren't really available. You can't really submit these to HJs for approval. One might look like, I think I have one open here. No. Let's see. Yeah, here we go. So this is what one might look like. This is one Hilti developed for similar structural beam through a wall. This is helpful when you're developing engineering judgments, and maybe your engineering judgment is based off some of these details. But this alone can't be submitted. It needs to be provided and sealed by a registered professional before you can actually and approved before you can actually use it. That's pretty much it. This is the list of resources. I think we'll send out this presentation to everybody. There's a bunch of links here. The first one is that UL database that I've kind of went through a couple of times. I encourage you guys to take a look and play around and do some searching to kind of familiarize yourself with it if you aren't already familiar with it. Next, two or three links here are a couple of very common suppliers of Firestop systems. Hilti, 3M, Passive Fire Protection. They should all have CAD and BIM details of their Firestops. They might also have like 3-part specs that you can use, and then all have documentation and a variety of selections of different types of Firestop systems that you can incorporate into your designs. The last two here are just some guides. These are very useful. For instance, 2007 Best Practice Guide. This is a guide, you might be familiar with it already. It's for fire stopping and sound transmission. It's published by NRC. It's called Best Practice Guide on Fire Stops and Fire Blocks and the Impact on Sound Transmission. It's about 200 pages and it has a whole host of really useful information on fire stopping, different types of fire stopping, where to use them, best practices on using them, different types of materials that can be used, guidance on engineering judgments, and some examples of how and where different types are used. And it also goes beyond just the NBCC or the National Building Code requirements and looks at some of the other requirements with the IBC and NFPA standards. Super useful, lots of information in here. I encourage you to kind of go through this. There's also the FCIA Firestop Manual of Practice. This should be free to access. You might just have to make a request to them. But again, tons of really good information. 400 pages or so on different fire stop materials, systems and selection analysis. So how to pick fire stops, what to look for. I think this one is also more um, directed to like contractors. So there's some guidance on inspections and what to look for on site when you're reviewing installed systems. Um, Tons of information here. Really great document. Again, links are provided for both of those manuals at the end of this. And I think we'll probably send out these slides to everybody for them to kind of have as their documentation. But that's it for me. I don't know. We've used up most of our time, but if there are some questions,
It's perfect,
please
perfect
fire away.
timing. Yeah, perfect timing. Thank you very much. I know Brian's been kind enough to be answering the questions as people have been asking them in the chat box. So if anyone wants to review those questions and look at the answers, some of them are pretty technical. Um, so I want to thank you, Gianni, again. Thank you for adding that section at the start as well about the architect's responsibility, not just as architect of record, but also as the CRP, the coordinating registered professional in having to oversee, yeah, the consultants review and ensure that they've been on top of that as well. Um, just quickly before we get into just some real quick questions here in the last couple of minutes. Uh, Again, thank you to you, Gianni, and also Brian, but also to Ori, Shannon, and Ella in my office who've been organising and hosting this event. And the great part of one of the great parts of this seminar was where you went through the product IQ and the Hilti websites, and just because obviously there's a theory here, but having that connection to understanding of how to actually apply that theory has been really useful. Could you talk a little bit? There was a question there about signing up to those websites and whether you need membership or whether you need to pay for them.
Yeah. So like Hilti and the manufacturer websites, you don't necessarily need to have a login, but you can. I think Hilti is useful because I think you can store the different searches you've made and kind of have a record of them. Let's see. The UL product IQ you do need to log in to access, but it's free. You should be able to just register and then you'll have free access and there's nothing beyond that you really need. Um, the only one that's a little tricky, I think it was the last one there, the FCIA, I think it was FCIA Firestop Manual Practice. I think this one you do have to, it says order now, but I think you can actually access it for free. You just have to make a request to them. It says FCIA offers complimentary PDF of the Firestop manual to architects and specifiers with design firms, etc. Inquire to receive your qualify. So you just have to send them a message. And you should be able to get access to it. So that one's a bit trickier, but other than that, everything else should be freely available. The one NRC document is, if you just Google it, you can also find it. It should be available for free on NRC's website in their archives. But I've also linked to the link I've provided is just direct to a PDF copy from a different website, but it's the same document. So again, free to access.
Fantastic. I think what we'll do, not only will we share the videos we've got a YouTube and I know Celerity, you have your own YouTube channel as well. So we'll share this video, but also I think when we send out a kind of a follow-up email here, it'd be great if we'll include all those links and resources as well in the body of that email. So you've got direct access to these websites. Um, just one, I guess, kind of time's up here, but just one last, just quick question here, just to confirm. We talked a lot about you talked a lot about engineering judgment here. Who can actually sign that? Who can seal that?
I mean, they're called engineering judgments. I've seen some done by architects. I don't know all the legality around that and what falls under architects area practice versus engineers. Oftentimes they're just like comparisons between existing listings. and that have been tested and approved and have specific ratings. So you might find 3 or 4 different listings that are very similar to what you're trying to do, but what you're trying to do hasn't actually been tested. And so it's very much a qualitative assessment. In that case, I have seen architects sign off on those. The AHJ might request that it's an engineer. It's going to depend. Our firm happens to be mostly engineers, are all engineers. So when we sign off on it, it's always an engineer that's doing it. And that's typically been accepted. So like I said, when you are going, if you are planning to go that route, it's usually a good idea to touch base with the HJ first to see if they have any special requirements for submission. They may request that it's signed off by a registered engineer versus an architect. And they may also require you submit it as, say, an alternative solution versus just a signed letter. So there's not a really well documented way, a guidance on engineering judgments. Everybody does it a little bit differently. And it'll vary from HJ to HJ, from firm to firm. So it's always good to get clarity from the HJ first on what their requirements are.
Brilliant. Thank you so much. I think what we'll do here is we'll just leave, Ori, if you could just leave this meeting running for another 5 minutes. If people want to go through the chat box here and just look at the questions and see all of Brian's fantastic answers to those questions, then please take your time in doing that. But from all of us, thank you so much, Gianni. Thank you to Celerity, and yeah, we hope to see you again soon. Take care.
Great. Thanks, everyone.
Thanks, everyone.